the first A. This is A. So I just put A here. For example, because you are going to design in your exam by yourself. A. I'm in A. Let us start from here. A. And from A, it goes to itself A when the input is 0. When the input X is 0, it goes, suppose that this is your next state, it goes to A itself. This is next, this is my present state. Because this A, I'm going to write it A, it will be 0, 0, like that's why I left this column. Because state assignment, I'm going to assign A, I'm going to represent A by 0, 0. That's why I leave this particular column blank. I'll fill it up. So from A, it goes to A when input is 0. Yes, when X is the input. When the input is 0, it goes to A. Next step, what about output Y? X is 0, X is 1, doesn't matter. What about output Y at that time? Tell me.
0.
0, yes. Is it okay or not? But for the present state A, output is always 0. So I will not write 0, just one big 0 here. This is, it doesn't bother about the input 0 or 1. It is not related. Output is 0 because the present state is A. For A, output is 0. Now let's go to B. The B. This B, for B, the output is always 0. So I can put 0 here, no problem. Or if you want to put 0, 0, 2, 0 also you can put, no problem. No problem, 2, 0 also you can put. I'm just putting 1, 0 for B. From B, when the input is 0, it goes to B itself. Okay, when it goes to B itself. And from B, it goes to A. Again, when it is B, when the input is 1, it goes to A. It goes to A. This is for B, output is 0. Now let me go to C. When it is C, it goes to the C itself when input is 1. Oh, then it goes to the C itself when input is 1. It goes to C itself. From C, it goes to D when input is 0. From C, when input is 0, it goes to D. And this C, when the present state of the circuit is at C, the output is 1. The output is 1. 1, 1 also you can write, no problem. And then let's go to D. D, it goes to D itself when the input is 1. It goes to D itself when the input is 1. It goes to D when the input is 1. Output is always fixed to 0 during the time. D, it goes to B when the input is 0. When input is 0, it goes to B. It goes to B. And output is also for D, state D. When it is at state D, output is 0. Okay. Now if you want to assign state A, let me call it 0, 0, B 0, 1, C 1, 0, D 1, 1, like that we'll do it. Then A, it will be represented by 0, 0 again here. C 1, 0, B 01, A 00, D 11, C 10, B 01, D 11, and so see when you so the most important thing is now this row, this column, this column, this column, and this column is very important for designing the circuit. This is not that important. This is very easy. You are just giving some name. You can give your name. You can give your friend's name, your name, your friend's name, another friend's name, another friend's name. No problem. Just any X, Y, Z, P, Q, R, anything. But that particular stat is represented by 2 bits. That is very important because we have 4 number of stats. 2 to the power what is equal to 4, 2 to the power 2 is equal to 4. So 2 is enough. So this is important. This particular row is important. Column is important. This column is important. This column is important, and this column is important for designing circuit. We'll design the circuit when time comes. Today itself we'll do it. But what I want here is to make you understand the difference between Moore circuit and Mealy circuit. In Moore circuit, it depends, output depends only on the present step. That's why output does not depend on x is equal to 1 or x is equal to 0. Here it depends on x is equal to 0 when x is 1, but output does not depend. So any question up to here? Any question? Any question? Am I audible?
Yes, sir.
Any question? Do you understand or not? Are you able to understand or not?
Yes, sir.
Yes, we understand, sir.
Okay, then I will move. Now, I am giving this, for example, I am giving this in the exam. I am giving this in the exam. For example, I am giving this particular state diagram in the exam, and I ask you to implement a sequential circuit, Mealy circuit. This is a Mealy circuit. How do you know it's a Mealy circuit? Because you just see in the state A, it is the output is not written together. Output is depend on input. Output depend on input, as well as in the state. Output depends on input. Left side is the input, right side output. Left side is the input, right side is the output. So if I give this particular diagram, state diagram, and if I ask you to design the circuit, what you're going to do is that you should be able to write the state table from this. You should be able to write the state table from this. And from the state table, you should see whether I can reduce my state table. In the sense, I'm having A, B, C, D, E. I'm having 5 numbers of states. If I have 5 numbers of states, I definitely require 3 numbers of bits. 3 numbers of bits means I may require 3 numbers of flip-flops. So I will write the state table from this state diagram, not a big issue. But another thing you should remember is that whether is there any possibility to reduce my state. That means here we have 5 numbers of states. From this 5, can I reduce to 4? Can I reduce to 3? If so, if I'm able to reduce my state, then I will be able to have lesser number of bits. If I have 4 number of steps, then I will be able to assign each and every step by just 2 bits instead of 3 bits. So state reduction is also important in case if the question is such that if there is some provision for reduction of the state, then you have to do it. That will simplify your problem. So here, let us see whether I can reduce my step or not. Let's say, let us write from here. I'll give you an example. Now I'm in A, for example. I'm in present state A. I'm in present state A. Now A, we'll go together. From A, it goes to, okay, let's see for 0. Input X, 0 or 1. Input X, 0 or 1. Input X, 0 or 1. Like this you write. It will be easy for you to design instead of writing X is equal to 0, 1 column, X is equal to 1 column, and then putting all those things. The way what I'm doing, X is equal to 0, 1, 0, 1 here, it will be easy for you. That is why I'm doing A, B, C, and D, and E, for example. And I'm going to have next state. This is my next. This is my present. This is my next. And output also, it depends on X and Y. So this is my output Y, for example. It also depends on the input because this is a mini circuit. So from A, when X is 0, when X is 0, from A, it goes to B. If I make any mistake, you please tell me. From A, it goes to B when input is 0 and output is 0. From A, it goes to C when input is 1. From A, when input is 1, it goes to C. It goes to C and output is 0. Is it okay? And then from B, let us say B, I will take another one, B. From B, when input is 0, it goes to D. From B, when input is 0, it goes to D. It goes to D, and output is 1. Output is 1. From B, again, it goes to E, when input is 1. From B, it goes to E, when input is 1. And output is 0. Output is 0. Is it okay? Can you write all this like this? Can you understand? You can proceed. So I'll let us not waste time. You can proceed like that. We have a state table like this. So they are writing like this. Output depends on the input. X is equal to 0, X is 1. X is equal to 0, X is 1. They are writing like this. So if you want to follow like this, no problem. If you want to follow like this also, no problem. Okay. So what I mean to say is that when you do this, when you do like this, you came to know, see, from C, when X is 0, it goes to C. And then when X is 1, the next step is D. Output also 0 when X is 0, and output also 1. And same thing, from E also, it is going to C again. From C also, it is going to C. From E also, it is going to C. And it is going to D under same condition, same condition, same condition. Then from C, it is going to C. This also E, I can say that from C, it is going to C. This E, I can say that it is C. Because I don't know from where it is coming, but the sequence are all same under all input conditions. So this also must be same. C and D must also be same. See, this one, that means this row and this row, these two are same. You can omit one of them. So you can omit C also, or you can omit E also. In this case, since when I say A, B, C, D, E, E comes at the last, so I will reject this E. I will ignore this E because this is meaningless. The same thing is happening, repeating in the third row. I will remove this E. We have decided. Then question arises. What question arises? What about this E inside? Though you have deleted this E, there is E appearing over here. Then how to solve? Then how to solve is that E is no longer there. You are cancelling. Then what you have to put here then? Instead of E, what you have to put here?
C.
Because E has been deleted.
0.
Instead of E, you have to put what?
C.
Yes, exactly, C, because they are same. That's why we have to get C. That's all. That's all. It's very easy. Wait. Someone is trying to join. Because I am going to ask, I am not going to ask direct question. I am going to ask questions differently. By this, I don't try to show myself that I am a very good this and that, I know everything. Not like that. I just want students to know. If they are knowing, they will be able to do. If they don't know, they won't be able to do. And that is why we are conducting exam. Otherwise, if everyone is getting 100 out of 100, there is no point of conducting exam. There is no competition in the entrance test and all. It's not required. So we have to filter the students. If the students who are hardworking, they deserve. If the students who don't hard work, they deserve to fail. So there should be difference. Otherwise, everyone cannot get the same job. The job will be very less, only one. 10 of you will be getting the same one post. How it is possible? Only one has to get. So anyway, so this is how I'm going to reduce my state. After reducing the state, will you be able to draw the diagram? Will you be able to draw the diagram? We can also draw the diagram because table and all these things are all we can change here and here. Let's say this is my A, and then anywhere I can I write B here, C here. I can write B here. Okay, B, C, D. Let's say. Now from this is done. This one has been cancelled out. So from A to B, when input is 0. From A to B, when input is 0. When input is 0. From A to B, when input is 0. And when input is 0, DC, when input is 0, output is also 0. Output is also 0. A to B. A to C, when input is 1. A to C, when input is 1. When input is 1, output is 0. Output is 0. B to D, when input is 0. B to D, when input is 0. When the input is 0, output is 1. Output is 1. B to C, when input is 1. B to C, when input is 1. When input is 1, output is 0. When input is 1, output is 0. C to C, when input is 0. C to C, when input is 0. And when input is 0, output also 0. Output also 0. C to D, when input is 1. C to D, when input is 1. When input is 1, output is also 1. Output is also 1. D to A, when input is 0. D to A, when input is 0. And when input is 0, output also 0. Output also 0. D to D, when input is 1. D to D, when input is 1. When input is 1, output is 0. Output is 0. So this is the state diagram of Mealy circuit. Is it okay?
Yes, sir.
So it is not difficult. So you should be very careful in the beginning. Don't do it very hurriedly. So here they are doing it differently. Different in the sense it may not be matching because A, B, or it should be matching from D to A. They are moving in this way. No problem. What they are doing is good because D to A I'm putting over here. You may get confused. This 0/0 is for this line, or it is for this line. 1/0 is this line, it will get confused. That's why from D to A, they just put it like this instead of putting over here confusion 0, 0 like that. No problem. It's up to you. If you are able to understand, then it is up to you. So this is the reduced state diagram. E is taken out. E is taken out. And instead of E, C is being substituted. It was supposed to be E. Yeah, it was supposed to be E earlier. So it is substituted by C. So it's substituted by C. And from this, we get this one. And that means A, I can represent 0, 0. B, 0, 1. C, 1, 0. D, 1, 1. That is state assignment. And by doing so, I can use only two numbers of flip-flops to design the circuit. We don't require 3 numbers of flip-flop. Circuit will be simple. And now we'll see how to design. So now someone wants to join, it seems. Let's see. Discard. This person, just now he's joined and then again, what is doing again? So we'll just see in the exam, I can ask anything in the exam. Like for example, a sequential circuit has, you have a sequential circuit, you have a big circuit, sequential circuit. One input, one output. The state diagram is shown in figure this. This is my state diagram. They're saying design the sequential circuit with a D flip-flop. They are asking to design this particular, the circuit for this particular state diagram, implement the circuit so that the circuit should perform the same. It is earlier in state this, it goes to the same state when input is 0, output is 0. Just things it has to satisfy, and you are going to design using D flip-flop, or you can design using T flip-flop, or you can design using RS flip-flop or SR flip-flop, or you can design using ZK flip-flop. So in the exam, I will not ask all 4. In the exam, I may ask implement using ZK flip-flop, or maybe SR or D or T, anyone, because all the 4 it may take a long time. And this diagram, state diagram, may be different in the exam. It may be different. I will ask something difficult where you need to reduce the state. So this is only 4, and then we will see whether a state reduction is possible or not. If not possible, then we'll go straight away, go ahead. And state reduction without reducing, if you want to do also, no problem. Those, because it is only two bits is required. If I reduce to 3 state, for example, it is also going to require 2 bits. So state reduction is just to make your task simple. Without state reduction also you can do, but the only thing is that you will have more numbers of flip-flops. That is the only thing. There is no wrong if you do without reducing the states, but it is not a smart approach. That is the only thing. So now we have to represent these things in terms of x when it is 0, when it is 1, or you can do x is equal to 0, 1 row, and x is equal to 1, another row, also you can do whichever. So you know very well. So I will not take much time how to convert it. Okay, you can convert it, right? Table you can draw it, no? It's okay.
Yes, sir.
Yes, sir.
Yes, sir.
So now this is table. As I said, present state. Now they are present state. They call it A, B, C, D. This A is being assigned as 0, 0. B has been assigned as 0, 1. No problem. This is how we have to do. Okay, they already have 0, 0, 0, 1. State has been already assigned by binary bits. No problem. Directly I'm putting, so none of all these things. But this A and B is nothing but 2 bits, A, B. And this is the next state. So sometimes in some other book, A plus, B plus, A plus, B plus, because it is next state. So if you want to write, you write. If you don't want to write, no need to write, because it itself says it is the next step. And the output also depends on the input when x is equal to 0, input when x is equal to 1. So the given circuit, or the given figure, I should say, the step diagram is a milli. It's a milli circuit, step diagram of a milli circuit, whose output depends on the present state as well as input. This is very simple. Now it has come like this. Now what we are going to do is that using D flip-flop, the first one is they are telling me using D flip-flop. Okay. Then I should know the excitation table of D flip-flop. The excitation table of D flip-flop is very simple. 0, 0, 0, 1, 1, 0, 1, 1. It is D, it is same. This is the excitation table. Okay. Then we have to find the expression of what? We have to find the expression of D flip-flop they are telling. So two numbers of D flip-flop will be using 2 bits. So two numbers of D flip-flop is required. DA, DB like that. And one output is required, Y. I need to find the expression for Y equal to what? I need to find the expression for DA for the bit number A. I need to find the expression for DB. So I need to draw 3 numbers of K-map. I have to draw 3 numbers of K-map. And those K-maps, the input of the K-map will always same. What will be the input? Always we are doing the present state as the input. That means AB as input. And we have another one, X also. X, it can be 0, it can be 1. And during that time, what is my AB? 0, 0, or 0, 1, 1, 0, or 1, 1. Okay, don't always focus in the next state. Always in the present state will come in the K-map. Okay. Can you understand what I'm saying? So now we'll see. Now this is for flip-flop. Flip-flop number A, bit A. Flip-flop number B, bit B. And for the output, as I said, you need 3 expressions. Y, DA, DB. For A, for B. Let's say AB, yeah, they are putting AB and they are putting X. And they have to find, oh yeah, DA, DB, and Y they are telling. So now how to fill up these things? You have to see you have to see what is that. Like for example, A, B, 0, 0. X is also 0. A, B, 0, 0. X is 0. X is 0. A and B is 0, 0. And X is also 0. One more. This thing is missing here. You will confuse. You will confuse. But even if it is missing, we can do. What I'm saying is that what I have to fill here. What things comes to your mind that I have to fill here? I have to fill the value of D, but D is not here. D is not here. Suppose, as I said, instead of writing the truth table like this, if you happen to write the truth table X is equal to 0, X sometimes 0, sometimes 1, sometimes 0, sometimes 1, 0, 1, 0, 1. Can you understand what I'm saying? Instead of writing like this, if I happen to write in X is equal to 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 like that, and we will write here DA DB, like that. DA, DB is missing here. DA and DB is missing here. If you want to put, you can put DA, DB, DA, DB. For beginners, DA, DB, if you reflect in this particular table, it will be easy for you to design. But for those who understand the excitation table of D flip-flop, there is no need of writing this thing again over here. Why? Because from the excitation table, we came to know that D is nothing but the next state. This is the next state. Whatever you are having here, 0, 0, you will come here 0, 0, 1, 1, 1, 0, 0, 0, and then here also 1, 0, 0, 0, 0, 1, 1, 0. Same thing you have to repeat here. Then what is the point of writing these things again here? What is the point of writing this thing again here? You are making things dirty. Don't you have common sense that the next state will be the same for D, because you are going to design using D flip-flop. In case of SR flip-flop, T flip-flop, JK flip-flop, it won't be like this. It won't be like this. JK, it has to be included in this table. But for D, if you want to include, you can include. Can you understand what I'm saying?
Yes, sir.
Do you really understand what I'm saying? Can you understand or not?
No, sir.
Who is saying no?
I did, sir.
Is there anyone who knows what I'm explaining? Is there anyone? Is there anyone who knows that what I'm explaining? We are going to fill up this. We are going to fill up this map. We are going to fill up. I'm telling very slowly. Okay, I'm not going very fast. I'm telling very slowly. And even if you are not able to understand, then I cannot help. Our aim is to fill up all this box. When A is 0, B is 0. When A is 0, B is 0. When X is 0. When X is 0. What should I fill here? This is for example, finding the expression for D flip-flop number A. Another same will be for D flip-flop number B. Another same will be for the output, as I have told. So same 3 numbers of KMM will come. So I have to fill all these things. What value do I have to fill here? Tell me. What I have to fill here? What I have to fill here? What I have to fill here?
No, sir.
That means you people are not listening.
No, sir. Confused. Confused. Can I select this one?
While designing one flip-flop from another flip-flop, realization of one flip-flop, realization of one flip-flop from another flip-flop, there also we have done it. So we know very well that we are going to design this particular circuit, the state diagram. This is a state diagram, the same circuit which should exactly match this state diagram that we are going to design using D flip-flop first. Then D flip-flop, RS, JK, one by one we are going to design. So using D flip-flop we are going to design, and we know the excitation table of D flip-flop. This is the excitation table of D flip-flop. Is it correct?
Yes,
Yes,
sir.
sir. Yes, sir.
Can you apply this in this box in the truth table? For a particular D flip-flop, only D, there is no D. One flip-flop, one D. One flip-flop, one D. One QM, another, next, present, next, D. If you know this, now you tell me what should be a DA. Everything is present in this particular table. Everything is present. Everything is present means everything is available. All information is available. Now, DA, in this DA place, what I should fill up here. You know,
0.
this D is 0, 1, this and that, it is coming. So what I should fill DA here? What I should fill?
0.
Why?
0, 0.
Why? No. I'm asking only for DA. You cannot write DA 0, 0 like that. You cannot do. One by one you have to do. You have to first write it for DA and then come DB. You cannot write both. For DA,
Because for a
tell.
next state
For-
is
For DA, it is 0. It is 0.
Yes.
You are telling it is correct. So 0. How you are saying this is 0? Based on what? Tell me. Based on what? By
based
looking
on
where
A value, sir.
this which one? So let us call it this one plus because next plus we'll call it. Okay. So
Plus our next state plus.
Now tell me. Based on what you are telling.
Plus state, sir.
Huh? Based on what?
Next state, sir. Plus.
Next step.
A plus.
This one. You are looking here.
Yes, sir.
You are looking here and telling, is it?
Yes, sir.
Why? Why you are looking only here? Why you are looking only here?
Because sir, it's
So-
next state
Next step. You are looking
in the
here and
D flip-flop.
now.
D is always equal to
Okay,
next.
okay, correct. Now let's say because we have to understand thoroughly, because questions may change in the exam. Question may change in the exam, so we have to know very thoroughly. Now let's say this is JK, or this is RS flip-flop, SR, SNR. SA, RA, SB, RB will come because we don't have space to write. That's why I don't write SB and RB. I'm not writing. If it is SR flip-flop, you're going to design using SR flip-flop. SR has 2 input. D is having only 1 input. So one flip-flop D, another flip-flop D. SR is just 1 flip-flop. So SARA, SB, RB also will come if it is SR flip-flop. Now, if it is SR flip-flop, then what should be my SA? What should be my RA? That means you should know the excitation table of SR flip-flop. Now, let me write the excitation of SR flip-flop. If it is SR, the excitation table is what I have to write here.
0, 1, 0.
0, 1, 0 D.
Hmm.
D 0, 1, 0.
Is this correct? No, you should remember this thing. And if it is JK, very simple now. If it is JK, this is JK. And if it is for T flip-flop, suppose T flip-flop is somewhere here in the middle. T flip-flop, toggle work here. Where is toggle? From here to here, no change. So 0. Toggle where? Toggle 1. Toggle 1. No toggle. So 0. 0, 1, 1, 0 is for T. For T flip-flop. 0, 1, 1, 0, 1, 1, 0 is the excitation table. So having all these things in your mind, now tell me SA, RA. What should be SA, RA? If it is SR flip-flop. If it is SR flip-flop.
D.
RI.
D.
क्या बोल रहा है? D. कहाँ से है भाई D? कौन सा दुनिया से है वो? Who is that guy?
Me, sir.
कौन सा दुनिया से D कहाँ से आएगा भाई? We are talking about SR flip-flop. There is no D. Oh, D.
0, sir.
Oh,
0.
D. D means don't care. I'm sorry. Yeah. D. I was confused. I'm the fool. You are right. Maybe. And let's say D means Sota D. Don't care, right?
Yes, sir.
Okay.
Yeah.
So I will put D, and let's check it. Let us see what you are saying is correct or not. Okay, I am confusing with this D. Okay, it is my fault. Anyway, so now what we are going to see exactly is that see 2 bits, 1 bit and 1 bit. For this particular bit, 1 flip-flop. For this bit, another flip-flop. That is why we require 2 flip-flop. So this bit for A, for this A, 1 flip-flop. For this bit B, another flip-flop, SRB. This is known to you because every flip-flop can store only 1 bit. So every bit, 2 bits, 2 flip-flops. Why SR flip-flop? Because S and R are input, so it is coming 2 here. If it is D flip-flop, only D will come, DA and another DB, that's all. If it is T, only T will come here, TA, another TB. Can you understand up to here?
Yes, sir.
And now,
Yes, sir.
now let's say A is 1 state. It goes to A plus, another state. A to A plus. A is 0 and A plus is also 0. So A is 0, it goes to the next state, A plus. That means A is 0 and next state is also 0. You see here. Qn is 0, Qn plus 1 is also 0. You see here. Qn is 0, Qn plus 1 is 0. At that time, my flip-flop SR will be 0D. Yes, what you're saying is correct. 0 and D. Now, I asked for this SB and RB, the next flip-flop. For this flip-flop, I have to go to the state B, not in the A. Earlier, B is 0. Now, B is also 0. Okay, this is my previous, and this is my next. 0, 0. And again, this condition, 0 and 0. Again, 0D. So I will write 0D here also. Is it okay? Likewise, I have to fill up everything. Is it okay?
Yes, sir.
Now, this is not the case now. Now they are telling using D flip-flop. So it is easy. D flip-flop is much more easy. D flip-flop is much more easy. D flip-flop is easy. So now, where is my this one. So I have two numbers of bit. So DA for bit number A, DB for bit number B. So one of the students, he was telling that by seeing here the next state, that is Q A plus B plus, A plus B plus is the next state, because as I said, D flip flop is the next state, the next state, then in the plus QN plus. This next state is exactly your D. So we can simply copy A. What is in A? 0, 1, 1, 0. 0, 1, 1, 0. We can simply copy. That is what he's saying. Correct. What he's saying is correct. But what exactly is the beginning or is the cause of this particular? I'm writing 0, 1, 1, 0. Where is the source? This is the source. We are checking here. 0, and we are checking here. Next 0, 0, 0, 0, like that. Why I'm telling this? For D, you are smart enough to say that this is basically equal to this. But if you remember like this, then for others, SR flip-flop, D flip-flop, JK flip-flop, you may confuse. So the best way is A present here. Next, A here. What should be my D? A, my present. My next A is here. What is my D? A is my present. My next A is here. What is my D? Can you understand? Similarly, here also, this is for X is equal to 1. Here also, same thing. A is my present. Now my next is A is this. My present is 0. My next is also 0. My present is 1. My next is 0. My present state is 1. My next state is 1. Is it okay? So for D flip-flop, I can write simply 1, 0, 0, 1. Now, this is for DA. I told you what it should come here. Now tell me what it should come here. This A and B is not your A plus, B plus. It is just AB. This is present. X is X. Your input. Now tell me, what should you put here in the first box? What should be in this?
0.
You see, okay, 0. What should be here? 0, 0, 1.
1. 1.
0, 0, 1. Let's see. 0, 0, 1. 0, 0, 1. Yes. 0. Present state 0. 0, 0, 0. X is 1. X is 1. No, I don't think so. A and B is 0, 0. Yes, A and B is 0, 0. A is 0. B is 0. A is 0. B is 0. And X is 1. X is 1 means this one. X is 1. So DA is 1. DA is 1. A is 0, B is 0, X is 0, it is 0. Yes, correct. So correct. What you observe is correct. Now 0, 1, 0. 0, 1, 0, 1. This is present state 0, 1. And X is 0. X is 0. Q is
1.
1. Now 1. 1, 0, 1. Then 0, 1, 1. 0, 1, 1. 0. Is it okay? 1, 0. 0. This is 1. 1, 0. 1. It is 0. 1, 1. 0. It is 0. 1, 1. 1. It is 1. Can you understand what I'm saying?
Yes,
you can
sir.
understand, no? You can understand.
Yes, sir.
Sir, we should next step now.
Huh? Yeah, this you understood, no?
Yes.
How
Sir.
it is coming. Then from this we have to like K-map. We have to do K-map. How is it possible? How is it possible? 1 is here, 1 is here. How is this possible? It's not possible. It's not possible. See, it is not possible. KMM here is there, here is there, here is there, here is there. So it is not possible. So you have to write by yourself. Write by yourself is what is the expression for this? This is A bar, B bar, X. What is this? This is A bar, B, X bar. What is this? This is A, B, X. Can you understand? What is this? This is A, B bar,
Yes.
and X, because we have to write like this only, because there is no combination possible. That is why they are writing like this. Similarly, for I should not waste time. Similarly, for DB, like this. Can you understand? So what I'm telling is no. Like you can do. It's up to you. Freedom. X is equal to 0. X is equal to 1. You can merge it in one particular column. X is equal to 0. X is equal to 1. Like as I said, no. X just X. 0, 1, 0, 1, 0, 1, 0, 1. Like that also you can do it. Like this. No need of making two columns. X is equal to 0, 1. Like that. Whichever is convenient to you, you do. There is no wrong, nothing wrong. And this is how you see things. How which is easy according to you, accordingly. For me, it is easy like this. Putting down all these things like this, I feel it easy for me. Anyway, it's up to you. This is the way how you have to fill up. And then what about Y? Y. This is the output Y. Very simple. Y. For suppose there is another box for DB, no problem. DB also we can do it. So instead of DB, if there is Y, then very easy Y also. A is what is present state A, what is the present state B. The first row is 0, 0, and what is the input? Input is 0, then output Y is equal to 0, so Y is equal to 0. Can you understand? Y will become 1 in 3 places. In 3 places, Y will become 1. And one of the places where Y will become 1 is when input is 1, and when input is 1, when input is 1, when input is 1, present state as okay. Here we'll get 1 here in the output Y. See, here we are getting 1 here in the output Y. So is it okay? So Y you can also easily write, no? Y Kabi, very easy. Y is only one output. Can you understand?
Yes, sir.
Because DA, DB, I am intentionally including here in the truth table that they have done in the book. They have not included. Why? Because they understood that A and B itself is my DA, DB. That is why I want to say. That is why in the book they don't include DA, DB, because they are smart. They know that DA and DB is going to be exactly the value you have here, 1, 0. 0, 0, 0, 1, 1, 0, like that. So it is exactly equal to this, it is exactly equal to this. So you can just see over here what is the bit string. Just see over here what are the bits. That itself is sufficient. No need to write DA, DB. That is what the book means to say. But it is not always true. If it is RS, you have to definitely write R, A, S, A, R, B, S, D, or S, A, S, R, S, R, like that. But for Y, it is only one Y. What is my present X, my present A? What is my A? What is my B? And then what is my X, whether it's 0 or 1? At that time, what is my Y? You just have to fill up here Y. What is the value of Y? When A is what? When B is what? When X is what? And what is that value of Y? We have to just fill it up from here. Is it okay? Easy, Y Kabi. If you don't understand, please don't simply keep mum. If one student understood, then I'm satisfied. Okay, are you able to understand or not?
Yes, sir. Understood.
Yes, sir.
Okay.
Yes.
Okay. Why kabi aa jayega aisa karke. So then from this also, what is the expression for this? We cannot combine. This is A bar, B, X bar. This is A, B bar, X. What about this? This is A bar, B bar, X. What about this? This is common. A is common, and then X bar, A X bar, A bar, B bar, X. A X bar, A bar, B bar, X. So like that we got it. So from this, we know DA mein kya kya jayega. What are the inputs going to DA? What are the inputs going to, because we know the function. DA is equal to this, DV is equal to this, dy is equal to this. The Boolean expression we have. Now you just simply have to draw DA. DA is equal to this, and get, and finally add. That is what? And get, and operation, and finally or operation. Is it okay? So you can simply draw like this. Y separately, and then this separately. You can mix up the things. Also, but it will look dirty. So from here I came to, because this A you have to connect A, ऐसा connect करना है, and B somewhere where B कहाँ मतलब B bar has to connect it. It will be zigzag. It will be very messy, dirty. The look. That's why, what is one flip-flop? What is my DA? What is my DB? What is my output Y? They are simply writing it. Is it okay?
Yes, sir.
मतलब difficult है क्या? नहीं, difficult नहीं है. ये तो यहाँ से तो draw किया ना. You already have the expression. Just this expression I am just representing it by means of diagram, logic diagram. That's all. समझ में आया कि नहीं आया? Is it difficult? If you don't have, if you don't understand, I can explain. But if you understand, then what is the point of explaining? Understand? Can I go next? Shall I go next?
Yes, sir.
Yes, sir.
Sir, yes.
Now using T flip-flop. So using T flip-flop, see in the book also they are recalling the excitation table of T flip-flop. Excitation table of T flip-flop. If you want to mark up, you can mark up 0, 1, 1, 0. Or for T flip-flop, it is very simple. There is a transition toggle, then T should be 1. There is a toggle from 1 to 0, so T should be 1. That's all. So T flip-flop. If you know T flip-flop, C now CC. Now they are writing in a different way. Input C. X is equal to this is what I want you people to follow. This is easy, no confusion. This is so X 0 and 1 X input when it is 0, when it is 1, when it is 0, when it is 1, when it is 0, when it is 1. No need of writing X is equal to 0, one particular column, X is equal to 1, one particular column, and INPUT input that we have done earlier. No need of like this, no need of putting like this. So this is easy to understand. And see, your input is separate and your next state is separate. It looks very nice. Your next state is here, your present state is here, your input is here, and my focus should be, I don't know whether other students are able to understand or not. If one or two are able to understand, that is enough. So now what I mean to say is that, what is my focus? My focus should be here. Present state and input. I'm going to make a truth table for K-map AB and then input X. That's all. So this will always be the input. In all the design, present state will be taken. Next state, how can you take next state? Next state तो बाद में आने वाला है, इसको बाद में आने वाला चीज को आप लेके कैसे डिजाइन करेगा? So present state and the input. And here, see, TA, TB. Why TA and TB? Because two flip-flops. A is 1 bit, B is another bit, 2 bit, 2 flip-flop, TA, TB. Why? Can you understand? This is very simple. This is quite elaborate, very, easy representation. So you always try to make the truth table like this, or I should not say the truth table, state table. Truth table is a wrong, wrong way of telling. This is a truth table for the particular state diagram. You can say truth table means always a truth. So this is not a truth table. This is a state table for the particular state diagram. I can say state table or excitation table, circuit excitation table. See in the bottom there, I think circuit excitation table. Don't say truth table anyway. So is it okay? From here also you can easily do it. No, Can you understand
Yes,
what I'm
sir.
saying?
Yes, sir.
Yeah, TATB. So you have one. So let us do it. You have one for TA निकालने के लिए one, another for TB, another map, and another for Y. Same input, AB, X, A, B, and X, A, B, and X. What are the things that you are going to put inside? Very simple. These are the things I'm going to put inside. Very simple for Y. These are the things. When will you put 0? 0. Where should I put 0? Very simple. I should put 0 when A is 0, B is 0, X is 0. Very clear from here. TATB. When are you going to put the 0? In which particular place? In which place? In the place of A0, B0, and X0. I have to put TATB 0. Can you understand? So, like this, you will have for TA, for TB, and for the output Y. Is it okay?
Yes, sir.
Then you can find expression very easily. TA is like this, TB is like this, and this is the output Y. Y equal to like this. Very easily you can find out. Once if you know this expression, you can draw it very easily. Now you are drawing it, joining together this and that. Why? Because it looks very simple. The expression is simple, so you are making connection like this. No problem. Is the sequential circuit. Clock is given together. No problem. TB. What is TB from here? TB is nothing but 3 numbers of AND gate and then 1 OR gate. 3 numbers of AND gate and 1 OR gate. 3 numbers of AND gate, 1 OR gate. TA. Okay, you will go here. TA is required only 2 numbers of AND gate and 1 OR gate. 2 numbers of AND gate and 1 OR gate. Similarly, you can do it using SR and JK. This is what I have written. SR JK आप कर सकेगा ना? I am not doing it.
Yes, sir.
Can you
कोशिश
understand
करेंगे.
क्या कोशिश कर सकते? You have to do. You can do it. क्या कोशिश करना? Because this is not a big issue. SR JK. I am not doing it because you have to do. Because every time you cannot say that sir हमने easy वाला कर लिया, difficult वाला हम लोग के लिए छोड़ दिया. ऐसा नहीं है. It's not like that, okay? Because here itself you can do it now for SR also. मान लो कि suppose if it is SR, then you just omit this one. I will tell you for SR. Output तो वैसा क्यों वैसा है? Same. Output will be always 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. Output 0, 0, 1, 1. Correct. Then 1, 1, 0, 0, 0, 0, 0. 1, 0, 0, 0. Correct. So output no problem. Output will be always same. So ये दोनों को हटाना है RS people के लिए. Then you have to write here S. It's my habit. SA, SR, RA, SB, RB. Then SR flip flop you have to 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 0, D, 0, 1, 0, D. This is S, this is R. This you know. Then come here. 0, 0, 0, not 0, 0, 0 and 0 for bit number 1. 0 and 0. 0 D. 0 D. ये भी 0 number B का 0 and 0. 0 D. 0 D. And then 0 and then 1. 0 and 1. 1, 0. 1, 0. 0, 0. 0, D. A. 0. A plus 1. 0, 1. 0, 1. 0, 0, 1. 1, 0. 1, 0. B. 1. B plus 1. 1, 1. D 0. D 0. 0 A plus is also 0, 0 0, 0 D, 0 D, B 1, B plus 0, 1 0 is 0 1, 0 1. Is that okay? You have to fill it up. Is it okay?
Okay, sir.
And then you have to find expression for what? You have to find expression for, so there will be there will be one expression for SA, another expression for RA, SB, RB, Y. How many K-map? You will have how many K-map? That means 1, 2, 3, 4, 5. 5 K-map. So using the 5 K-map, 1 K-map for SA, 1 K-map for RA, SB, RB, and Y. 5 K-map you will require. And from that, you will find expression for SA, RA, SB, RB, and Y. And then you have to draw. And what should be the input of what should be the input for each and every K-map? Always same. Your input should be the present state, AB, and input X. So these three ABX will be the input. So I think you can understand. So I will skip this one. Okay. It's going to be 4. Now quickly I will go for an example of quickly I will go for example of more circuit, because milli in the exam it can be more. So don't think that more difficult. No, it's not difficult. Input present state A, let's say, output is 0. It is D and output also 0. It is B and output is 1. This is more. It is C, output is 1. And it goes from B to D when input is 0. It goes from here to here when input is 0. It goes from here to here. Input is 0. It goes from here to itself. Input is 1. It goes from okay. When it is 0, it goes from here to here. When it is 1, it goes to itself. When it is 1, it goes to itself. When it is 1. Can you understand? Is it okay now?
Yes, sir.
So now how will I write present state? Because A is a state, B is a state, C is a state, D is a state. So I know I will not write A, B, C, D. Okay, I have to write first. Anyway, so I will change it. A is, so from this you came to know that it should be 0 0 0 0, because in the exam I will be giving like A, B, C, D, but you should know that A can be written by 0 0, B 0 1 0 1, because I don't have time. That is why I'm doing like this. And C 1 0, D is 1 1. Is it okay? No problem, no? You are assigning the state, no problem. Is it a problem?
No, sir.
No, sir.
No, it's not a big problem. Yeah. Now let's say, because I'm trying to this is my present state, present, and this is my input X, and this is my output next state, and this is my output Y. My output Y does not depend on X, and this present and X will be useful for making the K-map and all these things anyway. So now what I have to do, present is what, using ZK flip-flop. Shall we do using ZK flip-flop? Okay, now let us do using ZK flip-flop. Let us design a circuit using ZK flip-flop. So 2 numbers of bit, so 2 numbers of flip-flop, JA, KA, and another flip-flop, JB, KB, because I'm going to design using ZK flip-flop. So JK should come here, Y should come at the last, doesn't matter. Okay, this is my next step. So present state is 0 0. Present state is 0 0. Next state is also 0 0. Next state is also 0, 0. When my input is 1. Oh my God, I'm changed. No problem. When my input is 1. Okay, this is not the way, but in a proper manner it should go. 0 should come, but okay. From 0, 0, when input is 0. 0, 0, when input is 0, it goes to 0, 1. 0, 1. You just see here. From 0, 0, it goes to 0, 1 when input is 0. When input is 1, from 0, 0, then when it is 0, 0, output is 0. Can you understand? Then if you have any problem, you just tell me. From 0, 0, when input is 1, it goes to 0, 0 itself. When input is 1, it goes to 0, 0 itself. And present state 0, 0, present state 0, 0, output is always 0, output is always 0. So 2 times I'm writing, no problem. And now let's say B, 0, 1, 0, 1, 0 and 1. What happens? Output will be when 0, 1, 1. It will be always 1, it will be always 1. You can directly write. And then next step, 0, 0, 1 when input is 0. 0, 1 when input is 0. When input is 0, it goes to 1, 1. It goes to 1, 1. 0, 1 when input is 1. When input is 1, it goes to 1, 0.
1, 0.
1, 0. Yes, like that. Okay, then the next step is 1, 0. 1, 0. When it is 0, when it is 1. Next step is 1, 0. Okay, 1, 0, you have to 1, 0. 1, 0 is here. Output is always 1. Do you get that? 1. Then it goes to itself when input is 1. Input is 1, it goes to itself. That means 1, 0. When input is 0, 0, it goes to 1, 1. It goes to 1, 1 when input is 0. Okay, now last one is 1, 1, 1, 1. When it is 0, when it is 1, what happens? When it is 1, 1, always output is 0. 0, just write it. Then it goes to the same state when input is 1. It goes to the same state when input is 1. It goes to the state 0, 0 when input is 0. State 0, 0 when input is 0. Any problem here? Is it okay? Understood? Yeah. Then what you're going to do? Very simple. You're going to fill up JK, JK. Is it difficult? No, it is not difficult. You just have to know JK flip-flop 0, 0, 0, 1, 1, 0, 1, 1. And this is J, this is K. In general, what I know, Q, this is Q plus. What I know in general is 0, 1, D, D, 0, 1, D, D. That is what I know. So start filling up. Where should I see? I see present. I see my next. So present, which one is this one 0, 0. 0, 0 is 0D, 0D. The next one is 0, and this is 1. 0, 1. 0, 1 is 1D. 1D is for this flip-flop. Because each and every bit, one flip-flop. So first bit, first flip-flop. Second bit, second flip-flop. Because every present state and next step is represented by 2 bits. So this 0, this 0, then I have to match with this 0. 0, 0 means 0D. 0D is for this. This 0, and then this 1. 0, 1 is 1D. 1D. And then 0, this is 1, 1D. And 1 is also 1, 1, 1, D0. 1, and here again 1, D0. 1 and 0, 1 and 0, D1. 1 and 1, 1 and 1 is D0. Finish the first bit. Now you go to the second bit. Second bit is this one 0 and my 0. Present is 0, next is 0. 0, 0. 0, 0 is 0D. 1 and next one is 1. 1, 1 means D0. Can you understand?
Yes, sir.
Now I will not waste my time. Like this you have to fill up. Then your aim is to find JA. What is the expression? KA. What is the expression? JB. What is the expression? KB. What is the expression? Output Y. What is the expression? So you require 5 numbers of K map. 1 for JA, KA, another one JB, KB, and Y. You require 5 numbers of K map. And how the K map should look like? Yes, obviously the same. how many inputs you have present state. In my present state, I have 2 bits, A, B, they call it A, they call it B. In my next state, A plus, B plus, I can say. So this is my present state AB, you have to put AB here, 0, 0, 0, 1, 1, 0, 1, 1. And then this is my X. So present state and X is always the variable of your K-map. So this is X, 0, 1. Are you going to do K-map for JA? Yes, I'm going to do K-map for JA. Okay. So JA, you focus only in JA. Okay. So in exam, you are going to waste your time. JA, you are focusing in JA. You are again focusing in KA, JB, KB. Once you are looking here, you do it for all. Y also, JA, KA, JB, KB also. That means you parallelly draw all the 5 K maps. And when you are discussing about 0, 0, 0, then Y should be 0, JA should be 0, KA should be D, JB should be 1, KB should be D. Like that, continuously you just try to fill up all the 5 boxes simultaneously at one go. Otherwise, for this, you have to look again, and then again you have to look for KA. One by one, don't do. You are going to waste your time. Can you understand what I'm saying? You draw all the 5 K maps and go parallelly, because you are going to look for repeatedly. You are going to look. So no need to look for 5 times. Just look here. 0, 0, 0. What is my Y? What is my J? In my case, I'm writing only J. So J should be 0. J should be 0. Let's say somewhere. And then 1, 0, 1. 101. Where is 101? 101 is this one. 101 is this box. In this box, what should be my JA? JA should be D. JA should be don't care. So if don't care means it is very good at the time of making your K-map simplification of this thing using K-map. If don't care is there, you know very well don't care is will help you. Okay. So you will definitely find expression for JA, KA, JB, KB, and Y. Or if you want to try out in your home, I will tell you the answer. You can just check it out at home if you have time. What should be my F? F is equal to, okay, F means output. Okay, I'll write it here. Output. Output, there is nothing but Y, for example, equal to A XOR B. The answer is A XOR B. That is nothing but A bar B plus A B bar. That is the meaning. Okay, this is the expression for Y. And the expression for JA, JA will be equal to B. Because you have lots of don't care now, it will be very easy to simplify. It will be very easy. JA and JB, you will be getting JB is equal to X bar. You can try at home, okay? Just match, is it matching or not? You just try. And JA B, JB X bar, KA, you get KA is equal to X bar B. K of B is equal to X XOR A. It's nothing but can you understand? You just note down these things in your notebook and you just see whether it is coming or not. Okay, for your understanding, I'm telling. Any question? So the thing is that don't think that this is a different question. This looks very different. It is very difficult. No, if you know how to represent this particular state diagram to its corresponding state table, then everything is same, whether it is milli or more. The only thing is that this Y does not depend on the input X. So Y, you have to write whatever is the value, you have to write 2 times in order to make this looks beautiful in a proper way. It should appear. That's why I'm writing 0, 0 2 times, 1, 1 2 times. Okay, so can you understand what I'm saying? This Y, depends on the state. This is a state. X is 0, input X is 0, input X is 1. But at that time, what is the state? In that state, what should be the output? It should be fixed. In this particular state, the output is fixed, this one. In this particular state, the output is fixed, this one, 0. That's why I'm writing 2 times, 2 times. You know, to look it, you know, to make it look, what to say, in a proper pattern. That is why. So you have to match this answer. You can work out at home if you are interested. If you are not interested, don't do, no problem. It's up to you. As a teacher, I'm just giving you the advice. Whether you can try at home, you can just make it out, or it's up to you. So by this, we'll wind up. And then wait a minute. One important announcement I have to say that. So shall I discard? Shall I have you copied?
Yes, sir.
This answer? I'll discard.
Yes, sir.
Okay. So what I want to say is no. Exam, in the exam, final exam, theory paper. Since you people are too much, there are lots of people, more than 100. So I have requested all the individual departments to conduct exam invigilation. I'm talking about your theory exam, okay, main exam for this particular subject, EC 16 EC 301. Your individual teachers from your department will give you the Google link in the exam, okay, and then they will do the invigilation duty, because I cannot monitor, I cannot see all 100 students. So every department faculty will be giving that, the department will assign, I do not know, your HOD will assign. One faculty member will give you the Google link, and you are going to write exam in that Google link, in that Google Meet, not in my link. In my link, my student can join, only electrical. And regarding submission of your answer paper, and from where you are going to get the question paper, don't worry. In the Google Classroom, I will be uploading the question, and I will schedule the question, that exam. I will schedule the exam. So that exam will be in the form of assignment, because assignment I can schedule. You have to submit assignment. Assignment will be open from this time and it will be closed at this assignment. You will have your question also. I will write all the questions. Can you understand what I'm saying? So your questions paper, your questions will be available in the, what I should say, classroom. Your questions will be available in the classroom, Google Classroom, exactly at the time. And also I will give you the question paper in the WhatsApp group exactly at the time of the exam. Okay, it will also be available in the Google Classroom at the exact time. It will be available in your WhatsApp in the exact time, because exam is going to start at 10. Then, for example, 9:55, you will get your question paper 5 minutes in advance. Like that, I will do it. And submission, you don't submit your answer paper to the teachers, to your teachers, because you are submitting to your teachers' email, this and that. Lots of confusion will be there. So you are going to submit your answer paper only in the Google Classroom. Okay, you are submitting assignment, no, in the Google Classroom. You know how to submit assignment in Google Classroom. Electrical students, for them, they are submitting their records. They are submitting their records, lab records, in the Google Classroom. I am giving it as an assignment. They are submitting it. Similarly, that assignment will be your final exam on 16 EC 301, held on that, this and that. It will be highlighted exam, and in that you have to submit your answer paper, not in my Gmail, not in my Yahoo Mail, not in any other teacher's email. Just you submit your answer paper in the PDF form as an assignment, and the opening for that assignment will be exactly matching with your time period for exam. The time period for exam will be 1.5 hours maybe. So you will be allowed to submit your assignment, that means your answer paper, in the form as an assignment within that time period, 1.5 hours. Say from 10 it will start, then 11:30 it will be wind up. And whoever has submitted lately, it will be displayed late submission, late submission, late submission. I can easily know who has submitted late. For those who have submitted late, I can straight away. I will not check the answer paper, or on the humanitarian ground, I can check the answer paper, but they cannot get good marks because I'm going to reduce some marks for late submission. If it is too late, then I'm not going to check the answer paper. And sometimes due to some technical error, something may happen, then you have to inform me immediately by making a call, not by WhatsApp message. You have to call me directly, sir, I have tried to upload, it is not working. It is simply my network is this and that, it is doing like this and that. The reason you have to tell, because don't take it very lightly. So any question regarding an exam?
Sir?
Yeah.
Sir, can you give us 10 extra minutes for the making PDF and submission?
No
Because
problem. No problem. That I do. Normally do. Because I know I can understand. 10 minutes will be given extra. No problem. No doubt for that. No problem. That
okay, thank you, sir.
Okay, so you put your attendance in the. Wait. One more minute. One more thing. We have not. I have not given any assignment. I have not given any assignment. And assignment marks is 8 marks for assignment. So what I am thinking is, I will ask you 16 questions in the quiz. I will conduct a quiz assignment quiz. I will conduct an assignment quiz. There will be only 16 number of questions, 16. Each questions will carry half marks. Okay. So shall I do like that? And the questions will come from your engineering subjects, not from digital. It can be coming, 1 or 2 questions may come from digital, 1 or 2 questions may come from circuit, 1 or 2 questions may come from basic electrical, 1 or 2 questions may come. Oh, it cannot be like that. Computer, it's no way. Because computer, it will have different kind of thing. No way. From my subject only I have to ask. Okay. Quiz, I will ask 16 questions from my digital subject, and accordingly I will give marks for your assignment. Is it okay? Just 16 questions. 16 questions means in 20 minutes you have to do. Not in 20 minutes. 16 questions is very simple. Yes, no, true, false, 16. So 16 questions in 15 minutes you have to do. Otherwise, I know, because I was also a student, even I know, means like you people will call Google, you have another group, you will share the answer, this and that. So in order to avoid that, I will give only 15 minutes and you have to do 16 questions. Half marks, very simple. Yes, no, true, false, that type only. That I will give you the timing. Only 15 minutes, so I can conduct any time, maybe on Friday or maybe or any time I can conduct. Just 15 minutes time quiz in my subject. Will it be okay, no?
Yes, sir.
Yes, sir.
Okay, all the best for your exam. Exam is coming near, so we hardly have only 1 class. Don't miss that class. In that class, I'm trying to take up that digital to analog converter or analog to digital converter. Still, we have lots of things to do, but we don't have time. So don't worry. Whatever we are doing, it is important topic only I'm taking up. Important topics only. Those which are not important, I'm just because in future, in your higher semester, which all things may come, repetition, that things I'm doing. That is the only thing. Okay, so we don't have time, but we don't have time. At the same time, we have never wasted our time. We have never wasted our time. Is it like we have wasted some of our class? No, we have never wasted our class. We are regularly doing our class, but still we don't have time. That is not your fault. That is not my fault. Whatever we are able to get it from this, it is enough. Okay, so don't worry about the syllabus. Your class has been started very lately because of the lateral entry. The authority were telling to wait for this thing, no, lateral entry. That is why if we happen to start our class early,